This video is about concentration and dilution. First, let's recap. What is a solution? Well, a solution is a homogeneous mixture of two or more substances. It consists of a solute and a solvent. The solute is the substance that can dissolve in the solvent. Just note here that a solution can exist in any state, not just the liquid state. Components of a solution cannot be separated using mechanical filtration. This is the diagram that you're probably used to seeing to represent a solution. So we've got the solute dissolving in the solvent, and here we have our solution. So what does concentration mean? When talking about solutions, rather than talking about the number of moles present, we often talk about concentration, which in chemistry we call molarity. So concentration, or molarity, equals the number of moles of solute per volume of solvent. This is the equation that you'll often see to represent molarity. So capital M for molarity is measured in moles per litre and is represented in a formula as N over V for number of moles per volume in litres. You may also see this formula written this way. C for concentration equals number of moles per volume in litres. I think that this second one is better just because we already use capital M for molar mass, and when you are doing long calculations, it's easy to get them confused. But just note that you can see the formula written in two different ways. Let's talk more about molarity. You may see in the laboratory that a particular solution, say a solution of hydrochloric acid, is a 2-molar solution, and it is written like this. This capital M means molar solution, and it's a shorthand for moles per litre. This means that we have 2 moles per litre of that solution. If we have a 0.5 molar solution, it means we've got 0.5 moles per litres of that solution. How can we find molarity? Well, let's look at what we know already. We know that to find the number of moles, we divide mass by molar mass. We also now know that we have C for concentration equals N over V, so number of moles per litre. Let's combine these two formulas to approach this example. Our example says, what would be the molarity of a solution made from 86.5 grams of calcium hydroxide in 200 mils of water? Well, what's the formula for calcium hydroxide? We know calcium has a +2 charge and hydroxide has a -1 charge. So our formula is going to be CaOH2. And now we need to find the molar mass of calcium hydroxide. So first we're going to add 40.08 for calcium, and we've got 2 times 16 for our oxygen and 2 times 1.01 for our hydrogen. Altogether, that's going to make 74.10 grams per mole. So that is our molar mass for calcium hydroxide. We now have all the information we need to plug some values into this formula and find the number of moles. So rewriting our formula out, we've got N equals little m over capital M. And up the top here, you can see we've got 86.5 grams, which is our mass, and our molar mass we've just found. Plugging that into the calculator, we're going to get 1.17 moles of calcium hydroxide. We're now going to use this information in our second formula in order to find molarity. Remember, molarity means concentration. First of all, concentration is in moles per litre, but we've been given a value in millilitres. That means we need to convert this into litres in order to put it into our formula. So dividing by 1,000, we get 0.200 litres. Now we can plug it in. So we've got 1.17 moles divided by 0.200 litres. which will give us 5.85 moles per litre, which we can write as a 5.85 molar solution. Let's talk about dilutions. We can alter the concentration of a solution through dilution. Dilution is where we add solvent to a solution. If the number of moles stays the same, the solution will become less concentrated as we add more solvent. Dilution calculations use the following equation. C1V1 equals C2V2. So C1 represents the first concentration, V1 the first volume, C2 the second concentration, and V2 the second volume. Again, you may see the same formula written this way with M instead of C standing for molarity, which is the same thing. Again, I'm going to say that since we're already using capital M for molar mass, I prefer to use this equation where we use C for concentration, just to help reduce confusion. Let's do an example dilution calculation. To what volume would you need to dilute 200 ml of a 5.85 molar solution to make it a 1.95 molar solution? Let's write out our formula to start with. C1V1 equals C2V2. Now we need to find our variables. Our first concentration is 5.85 molar solution. Again, we need to convert this to litres. So we've done the same one on the previous page, divide by 1,000 to get 0.200 litres, which is our first volume. And we want to change this to make it a 1.95 molar solution. So this is our second concentration. Now our second volume is what we're looking for. That's our unknown. Now that we know what everything is, let's rearrange this formula to make our unknown, V2, the subject. It's going to look like this. All I've done is move that C2 onto the other side of the equal sign by dividing. Let's plug our values in. So we've got our C2V2 up the top, C1V1 up the top, and our C2 down the bottom. What you'll notice here is that the two units, M for molarity, are going to cancel out. And the only unit we have left now is L for litres, which is what you'd expect since we're after a volume. This is what we get when we type this into the calculator. We have 0.600 litres of volume for V2. Just note here, you need to read questions carefully. Some questions might ask you how much solvent you need to add. That would require a subtraction as an extra step at the end. So if you have 0.2 litres and you need your solution to be 0.6 litres, you would just subtract 0.2 from 0.6 to find out how much you need to add for your new volume.